Welcome back to the third iteration of my R-short series, Linear and Multiple Regression. In the first portion of this iteration, we had looked at linear regression, and then the video kind of went over time, so I had to split it into this second section, which is multiple regression. And so this video kind of depends on you having seen the first video. However, if you did not and you just came here without watching the first one, I'll just quickly go over what's in the R script window here and why we did what we did. So as with all of my videos so far, we are using the Palmer Penguins dataset. So I went ahead and loaded up the tidyverse, the Palmer Penguins, the Penguins dataset, and I libraried a package called psych for its pairs panel function, which I'll get into in a minute. And then I set the option SciPen to 999 to get rid of scientific notation, which will make our summary of the regression analysis much easier to understand. And so I was talking about this pairs panel function earlier, and here's what it does when you run it. And again, if you don't want to type this manually, you can go to my blog or to my GitHub to copy the code. And so the graph that this spits out is basically a pairwise comparison of all the variables that I've inputted into the line of code, which are all of the variables that are relevant to the Penguins dataset. And what we had said from this is that we will be taking a look at flipper length, bill depth, and bill length, because they all share, a decent amount of variability. And so in the first section, we had done a linear regression comparing, or not comparing, but a linear regression with flipper length and bill length. And then we went over that. And so quickly, let's look at what we went over here. So not to waste too much time, but basically when you look at this summary, what you're interested in looking at is the p-value of your coefficient of interest, which in this case is bill length. The p-value down here of your residuals, and then the multiple R squared, which in this case was 0.43, which means that 43% of the variability in flipper length was accounted for by bill length. And now let's go ahead and build upon this model and add in bill depth on top of bill length to see if we can account for more variability in flipper length. So the way we do this is actually pretty simple. So I'm going to go ahead and copy most of this script, or most of this code, and then change this so it won't be linear regression, it'll be multiple regression. And then to add another variable into my model, another predictor variable into my model, all I have to do is add a plus sign and then the name of the other variable, which in this case is bill depth in millimeters. So let's go ahead and run that. And we get a very similar summary from the first video, from the linear regression, except that in the coefficients this time, we have both bill length and bill depth, obviously because we have, both of them. All right, so we've already taken a look at bill length here, so we don't really need to worry about it. The only thing we need to worry about for this video is the new predictor variable and its p-value, which again is much less than 0.05, which means we can go down to the residuals and again look at the p-value, which again is less than 0.05. Great, now we can look at the R squared values. Now, for the linear regression, we had looked at the multiple R squared. However, for the multiple regression, we'll be looking at adjusted R squared, which, they're pretty similar, but sometimes they can be quite different. And especially when you're right at the border of significance, it can kind of tilt things one way or another. But for here, for this instance, it doesn't matter all that much. So what we get here is a value of 0.6237. This means that 62.37% of the variability in flipper length is accounted for by both bill length and bill depth. And there you have it. That is how you run a multiple regression in R. I hope you enjoyed the video.